Hello dear students. In the previous lecture we have discussed static characteristics of measuring instrument, and we have discussed first scale range, then span, and accuracy, precision, error, calibration, resolution, threshold. And last we have discussed sensitivity. Today we are going to discuss remaining static characteristics. The next characteristic is repeatability. The repeatability. What is repeatability? Means we have to repeat something. So the ability of the measuring instrument to repeat the same result during the measurement for the same quantity. But there is a condition that during the measurement, the machine will remain same. The operator over a short span of time will remain also same, and the value of input that is given the under the operating conditions will always remain same. So it means if you are measuring 20 ampere of current with the help of ammeter, so this 20 ampere will remain same, and the condition, operating condition, it means temperature, pressure of air, it means all the things remain same. So when you will measure this kind of thing and the input remains same for the short span of time, and same operator is taking reading again and again, then the output will also see. For example, आप 10 एम्पियर मेजर कर रहे हैं, तो 1 सेकंड के बाद भी अगर आप मेजर कर रहे हैं और 10 एम्पियर इनपुट दे रहे हैं, तो आपको 10 इनपुट ही 10 एम्पियर ही रीड होना चाहिए. ऐसा नहीं है. इट मे बी 9.99 एम्पियर और इट मे बी 9.98 एम्पियर, but it should always be remain same throughout the span of the time. Okay, so this is called repeatability. Next is reproducibility. There is slight difference between reproducibility and repeatability. In repeatability, all the things remain same. The input, the machinery on which we are taking the measurement, the operator will remain the same, the operating condition will remain the same. But in reproducibility, what is happening? If we are measuring a quantity, then the condition of measurement can change. For example, there are number of operators which can take the reading of same input. Okay, so and different environment condition and different measurement. For example, we have 1 ampere meter and we have to measure the current of 10 ampere. So I can also measure 10 ampere, or another person you can say X person. X person also measure 10 ampere. Okay, so आप बेटा 10 एम्पियर एक एमीटर से मेजर करते हैं, फिर सेकंड पर्सन आता है वो 10 एम्पियर एक उसी इंस्ट्रूमेंट से रीड करता है या दूसरा एमीटर लगा के ऐड करता है, बट वो 10 एम्पियर सेम रहता है, इनपुट सेम है, बट आपने इंस्ट्रूमेंट चेंज कर दिया. ऑपरेटर भी चेंज कर सकते हो, एनवायरमेंटल कंडीशन भी चेंज कर सकते हो, लेकिन आपको रीडिंग कैसे मिल रही है? मान लीजिए आई हैव रेड इट 9.998 एम्पियर, अदर पर्सन रेड इट 9.96 एम्पियर. So it means the reading are reproducing itself. So this type of characteristic of any measuring instrument is called reproducibility. In repeatability, all the things will remain same. In reproducibility, the input will remain same, but the instrument can get changed, the operator can get changed, the environmental condition can get changed. Okay. Next is readability. Readability means to read something. Readability means to read something. We can say that readability refers to the ability of the user to read to the smallest unit on the measuring device use specific inspection procedure. For example, if you are reading a length with the help of scale which is having the fine graduation line, each line are very close to each other, so it is very difficult to read with your naked eye. You have to use a microscope or magnifying glass to read that value, and if all the divisions are at some space, at some distance, so it is very visible with your eyes, so you can easily read it. So the readability of the instrument is should be very good. So this is the property to read something. So readability of measuring instrument should be good. If the readability is not too good, then you have to use extra objects to make it visible. For example, magnifying glass, etc. Okay, this is readability. Next is drift. Drift is what? Bitter drift is a kind of error, but it counts in the characteristic. Drift occur as an error due to the frictional changes or mechanical stresses or chemical structural changes. आपने देखा होगा कभी कभी एमीटर आपने देखा होगा या वोल्ट मीटर जब भी आपने रीडिंग ली है तो उसका जो पॉइंटर है कभी कभी आपने देखा होगा जीरो से आगे रहता है, उसमें कोई भी इनपुट नहीं लगा होता तभी उसमें रीडिंग 1 या 2 कुछ शो हो रही होती है, तो उसमें क्या ये आपकी ड्रिफ्ट है, ये ड्रिफ्ट है। ये कभी कभी ऐसा होता है कि आप इनपुट ले रहे हो और धीरे 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 जीरो से वैल्यू आप रीड कर रहे हो, आगे रीड करते हो और बढ़ती चली जाती है आगे वैल्यू, जबकि आपने आउटपुट दिया 10 एम्पियर लेकिन वो आपको शो कर रहा है 11 एम्पियर। तो वो पॉइंटर के अंदर मैकेनिकल डिस्टर्बेंसेस आ गए हैं, केमिकल चेंजेस आ गए, उस वजह से आपका जो एरर डेवलप हो जाती है, दैट इज कॉल्ड एज ड्रिफ्ट। Okay, so drift are of three types: zero drift, sensitivity drift, and combined drift. So first we will discuss zero drift. So the very first diagram, that is A, is showing the zero drift. Zero drift को बेटा मैंने अभी एक एग्जांपल दिया है, जैसे एमीटर में आप एक एमीटर ले रहे हो, उसमें रीडिंग लेनी है आपको, और एमीटर का जो पॉइंटर है वो जीरो पे नहीं है, 1 एम्पियर पे शो कर रहा है, तो आपको 1 एम्पियर को ऐसे जीरो मानना पड़ेगा। ठीक है, ये जो ग्राफ है ये यही शो कर रहा है, ये आपका मान लीजिए प्रेशर है, ये स्केल रीडिंग है, आपकी जो एग्जैक्ट लाइन शो होनी चाहिए जो रीडिंग की वो ये शुरू होनी चाहिए डैश लाइन, बट मैकेनिकल स्ट्रेसेस और केमिकल चेंजेस की वजह से आपको जीरो नहीं शो कर रहा, वो कुछ रीडिंग शो कर रहा है, फॉर एग्जांपल 1, तो वो 1 को ही आपको जीरो लेके करना पड़ेगा। तो इट मींस दिस जीरो ड्रिफ्ट, line of zero drift should be parallel to the nominal characteristics drift। ये वाली जो ड्रिफ्ट है इसमें कोई भी एरर नहीं है, बट आपका केमिकल स्ट्रेसेस और चेंज और केमिकल मैकेनिकल स्ट्रेसेस और केमिकल चेंजेस की वजह से क्या हो गया, आपका जीरो शिफ्ट कर गया और 1 से अब आपको रीडिंग लेनी पड़ेगी। दिस टाइप ऑफ ड्रिफ्ट इज कॉल्ड एज जीरो ड्रिफ्ट। नेक्स्ट इज sensitivity drift। next is sensitivity drift। sensitivity drift is what? The initial point starts from zero itself, but the change take place gradually with the increase in result. For example, this is the nominal characteristic, this is the nominal characteristic, but you see that this dark line is diverging from this nominal characteristic line. It means this is a variation, this is the variation which gradually increases with the result. For example, if the final result is of 10 ampere, then it is showing you 11 ampere. So this is the gradual shift of the whole reading. This is called as the gradual shift of the whole reading. This is called as sensitivity drift. It means it is sensitive, its sensitivity is affecting. This drift is affecting the sensitivity of the measuring instrument. Okay. And next, and the last is combined drift. Combined drift. Combined drift means the combination of zero drift and the sensitivity drift. So what is this? In the zero drift, the value starts from some initial point, that is from 1 or 2 instead of 0, and it is gradually shifted from the nominal characteristic to the above part. For example, here the distance is less, here the distance is more, so it is gradually increases from some point that is not 0, it is some having the value that is like 1, 2, 3, so it is a gradual shift. So that is why it is called as the combination of zero drift and sensitivity drift. Okay. Next type of characteristic is hysteresis. Basically, hysteresis also a error. Hysteresis also a error which occur due to friction, elastic deformation, magnetic characteristic. बेटा सबसे पहले मैं इसका एग्जांपल दूंगा। आपने स्प्रिंग बैलेंस आप सबने देखा होगा। स्प्रिंग बैलेंस में क्या वेट लगाते हो तो स्प्रिंग रिफ्लेक्ट होती है और पॉइंटर आपको शो कर देता है 2 kg या 3 kg जो भी आपका फोर्स लगाया है आपने, है ना। विद द यूज, आपका जैसे जैसे यूज होता जाता है स्प्रिंग बैलेंस, बाद में आप देखते हो कि आपकी जो स्प्रिंग है वो जीरो नहीं कुछ वैल्यू दिखा रही है ऑलरेडी, तो वो वैल्यू ऑलरेडी कुछ दिखा रही है। तो आप क्या करते हो कि पहले आप धीरे धीरे एक एक वेट लगाते हो, या आपने लैब में भी प्रैक्टिकल किया होगा, 1 kg रखते हो, फिर 2 kg, फिर 3 kg, फिर लेटेस्ट सपोज आपको 5 kg अचीव करना है, आप पहले 1 kg रखोगे, फिर 2 kg करोगे, फिर 3 kg करोगे, मतलब 1 kg उसमें ऐड करते चले जाओगे, ठीक है। तब रीडिंग देखोगे आपको क्या मिल रही है, 1 kg पे क्या मिल रही है, 2 kg पे क्या मिल रही है, 3 kg पे क्या मिल रही है, 4 kg पे, 5 kg पे क्या मिल रही है। फिर इसका जस्ट रिवर्स प्रोसेस करोगे, अभी आपने लोडिंग की है, अब अनलोडिंग करोगे, यानी कि 5 kg से 1 kg रिमूव करोगे तो 4 kg आ जाएगा, देन 4 kg से, अब इस तरह से फिर आपको हिस्टेरेसिस की प्रॉब्लम जो होती है, जो एरर होता है मैग्नीट्यूड ऑफ एरर, इस तरह से रिमूव करना पड़ता है। तो हिस्टेरेसिस को रिमूव करने के लिए क्या करते हैं, हिस्टेरेसिस कैन बी एलिमिनेटेड बाय टेकिंग रीडिंग इन बोथ द डायरेक्शन एंड टेकिंग द अर्थमेटिक मीन ऑफ बोथ द डायरेक्शन रीडिंग। जैसे मैंने अभी स्प्रिंग बैलेंस का बताया कि आपको पहले 1 by 1 वेट इंक्रीज करके रखना होगा और फिर उनको 1 by 1 डिक्रीज करना होगा। तो जो आपकी रीडिंग है उसका एवरेज कर लीजिए, एवरेज करने के बाद जो आपका रिजल्ट मिलता है दैट इज योर फाइनल वैल्यू ऑफ मेजर्ड रिजल्ट। सो दिस इज द error which occur in the measuring instrument due to friction, elastic deformation, magnetic characteristics, etc. Okay, and this is the diagram of hysteresis, which is showing you the, this is the increasing input that you are loading the instrument, and this is the line, and now you are decreasing the input value. So by taking the mean, you will get the final value of measured value. Okay, and this dashed line is indicating you the idealized straight line. In all the case, in the normal case, you will get the value from 0. It will start from 0 and you will get the final value. Okay, so for removing hysteresis, you have to load the instrument 1 by 1 and then remove the object from the instrument in a decreasing order, and after that what we have to do, we have to take the arithmetic mean, you will get the final reading. So this is all about the static characteristics. Okay, so next type of characteristic is dynamic characteristic. So in the previous lecture I have already told you that what is dynamic characteristic. Dynamic characteristic are the characteristic that depends upon the variation of time. So these are there are the dynamic characteristic like speed of response, measuring lag, fidelity, and overshoot. So first we will discuss speed of response. Speed of response means the time which are taken by the measuring instrument to give the result. So it is defined as the rapidity with which a measuring system responds to change in the measured quantity. If let us suppose there is 1 kg on a spring balance and you have again add 1 kg more, so it become 2 kg. So then what is the time taken by the measuring instrument to achieve 2 kg from 1 kg? 1 kg से बेटा 2 kg अचीव करने में उसे कितना टाइम लगा? It is called as speed of response. It is called as speed of response. Next is measuring lag. Measuring lag means it is the retardation of the delay in the response of measuring system to change in the measured quantity. बेटा ये क्या है, किसी भी वजह से हो सकती है measuring lag, जरूरी है हो, अगर होती है तो there is some error, some frictional error or something else. There is some delay in the response of measuring system. Next is fidelity. Fidelity means degree of closeness with which the system indicates or record the signal which is impressed upon it. Ability of the system to reproduce the output in the same form as the input. बेटा एक तरह से आपका क्या है कि एक्यूरेसी है, लेकिन ये टाइम डिपेंडेंट है कि आपका जो सिग्नल है वो ऐसा तो नहीं है कि अप एंड डाउन हो रहा है, बार बार अप एंड डाउन हो रहा है तो आपको इतना क्लोज मिल रहा है वो स्टैंडर्ड के, अप एंड डाउन होगा तो वो स्टैंडर्ड के क्लोज तो मिलेगा लेकिन उस पर कुछ टाइम कंज्यूम होगा. सो दैट इज व्हाई इट इज केप्ट इन डायनामिक कैरेक्टरिस्टिक. इट इज अ डायनामिक कैरेक्टरिस्टिक फिdelity, degree of closeness with which the system indicate or record the signal which is impressed upon a, मान लीजिए अगर some weight is kept over a weight machine, electronic weight machine, and it is to be recorded. So the time taken by the instrument to record that signal, and it must be near to the input signal. जो आपको input दिया, let us suppose it is 10 ampere, so output should also be near to the 10 ampere. Okay, so but it is a time dependent process. Next is overshoot. Overshoot is what? If you do the practical in electrical lab in first year, then sometimes you have seen that if 10 ampere current is flown through a uh, wire and ammeter is measuring it, then what happens? Pointer from zero start moving to upward, it should have to stop at 10 ampere, but it goes above 10 ampere and then return back to the 10 ampere to show the final reading. So this type of condition, the overshoot means 10 ampere से ऊपर जाएगा, तो वो जो होता है वो आपका overshoot है. It is because of mass and inertia of the moving part. The pointer of the instrument does not immediately come to rest in the final detected position. The portion up to which pointer moves and then return to the final steady condition. It means मैंने अभी आपको example दिया है, ammeter 0 से start होगा, then it will move more than 10 ampere and then it return back to 10 ampere to show the final result. So जितना आपका pointer 10 ampere से ऊपर गया, that is your overshoot. So this diagram is showing you the overshoot. This is overshoot. This is overshoot. This is overshoot, and finally you will get the reading. Okay. So this is all about the dynamic characteristics. Thank you so much, and have a nice day.